to find the measures of those missing arcs, let's say this arc right here, what will we do, Brittany?
Subtract one. Wait, which one?
Well, I mean, you can pick. Let's do this one right here.
Okay, just subtract 70 by 180.
70 minus 180?
No. 180 minus 70.
Okay, yeah. So since this right here is a diameter, then we know that this is a semicircle, and we know the measurement of a semicircle is 180, so we'll subtract the 70 here, and we get 110 for that one. Okay, and then over here, we're going to do the same thing, because we know this arc plus this arc are going to form a semicircle, and so they're going to add up to 180, which makes this one what? That one's going to be 30. So let's get that in there here. So that arc right there is going to be a 30-degree arc. And so we can use the measures of those 4 arcs to find the measures of each of those angles. Those are the 4 arcs. Those are the 4 intercepted arcs that we're going to use for those angles. And actually, I think the 150, we're not going to even really use the 150 at all. That's not an intercepted arc for any of them. We just needed that so that we could find the 30-degree angle. I'm sorry, 30-degree arc. Angle 1 is what kind of angle?
Central.
It's a central angle. And the central angles are easy because the measure of the central angle is the same as the measure of
the arc
the intercepted arc. So angle 1 intercepts the 70-degree arc, so that means that the measure of angle 1 equals 70. Okay, that one's easy. How about angle 2? What kind of angle is angle 2? It's inscribed because the vertex is on the circle. So for an inscribed angle, and I'm gonna use this highlighter here quite a bit. For an inscribed angle, we're going to look at the intercepted arc. So what part of the arc, or what part of the circle is inside of that angle? The 30-degree arc, right? So the 30-degree arc is the intercepted arc. What's the second one? Remember we said every angle has 2 intercepted arcs. So what's the second one? We have the 30-degree arc and the 0, right? It's really inside of the vertex. If the vertex was a little bit inside or a little bit outside, we would have one, but here it's going to be 0. So the intercepted arc is going to be 30 and 0. So we're going to have what? Somebody set the equation up for me. 30 plus 0, you don't have to have the plus 0 in there, divided by 2, and we get what? 15. Does that make sense? Okay. How about angle 3? What kind of angle is angle 3? 3 is not an inscribed angle. The vertex is right here. It's an interior angle. We're going to use the same formula whether it's in interior, exterior, inscribed, but we just want to kind of have an idea of what it is. Since it's an interior angle, if you remember the direction of the angles in the arcs, they're going to be going in the same direction. So both of them are going to be positive. So what we need to look at now is the intercepted arcs. So coloring inside of the angle there and its vertical angle over here. What are the 2 intercepted arcs going to be? Okay, the 30 on the one side and the 110 on the other side. So how are we going to measure that angle?
110 plus 30 divided by 2.
And what do we get for that, Malik?
70.
Yeah, 110 plus 30 is 140. Divided by 2 is 70. Any questions about that one? What kind of angle is angle 3? I'm sorry, angle 4. It is an inscribed angle. So again, with the inscribed angle, we're going to have one of the intercepted arcs is really inside of the angle. So we only really end up with one intercepted arc, which is what? Everybody at the same time? 110 degrees. I'm going to go ahead and do the shortcut here. So the measure of angle 4 is 110 plus 0. So we won't even write that in, divided by 2, which is 55. Okay. Angle 5 is what kind of angle? That is exterior. So both of the intercepted arcs are going to be on the same side. So shading in that angle there, what are the two intercepted arcs going to be? 30 and 110. Because of our directions, though, because of the counterclockwise direction, one of those is going to be negative. Which one's going to be negative? The 30, the closer one. Exactly, Sam. So the 30 is going to be negative. So we're going to have 110 minus 30 divided by 2. 110 minus 30 is 80. Divided by 2 is 40. And angle 6 is what kind of angle? Inscribed, because the vertex is on the circle. So filling in that angle right there. What part of the circle is inside of the angle? The 110 degree angle. So that actually means that this is going to be the same as which one? Same as angle 4. Because angle 4 intercepted the exact same arc. In fact, any inscribed angles that intercept the same arc are going to be the same, right? Because if they intercept the same arc and you divide by 2, you're going to get the same thing every time. So it doesn't matter where the vertex is as long as it's on the circle. If it intercepts that arc, it's going to be 55 degrees. How do you guys feel about these? Pretty confident? You hate them? Is that what you said? Okay. Sorry. Okay, moving on. What's up, Cody?
So you add
I did have the question yesterday, is the 140 degree arc this one or this one? Who can tell me? On the left or the right? It is the one on the left. Why does it have to be the one on the left? Look at the way I named it. Is it a minor arc or a major arc? It's a minor arc. It has to be a minor arc because there's only 2 letters, right? Since it's a minor arc, and really since it's less than 180 degrees, we don't even have to know because of the name, but it is less than 180 degrees, it's going to have to be the smaller arc. And remember what I said yesterday, the smaller arc for an exterior angle is always going to be the one closer to the vertex. Always. Okay, so AC, the measure of arc AC, that's referring to this arc right here, 140 degrees. Now, to find the measure of angle B, or angle CBA, we need to use both of the intercepted arcs. Notice here that this angle intercepts AC there and the major arc AC on the other side. So, what do we need to do? Jimmy?
Do we need to figure out the measure of the other arc?
Yes, we need to find the measure of this arc right here. Brittany?
360 minus 140.
Yeah, exactly. So to find the measure of that arc right there, we'll do 360 minus 140, and we get what? 220. So the measure of that arc right there is 220. Then how do I find the measure of this angle right here?
220 minus, or,
Yeah.
220 minus 140 divided by 2. What's 220 minus 140? 80 divided by 2 is 40. So we get 40 degrees there. Now, this kind of problem gets a little bit trickier, and I'm not going to, I don't need you to write this down, but I want to show you the problem. If we were doing the opposite, and by opposite I mean I gave you the if I give you the measure of the angle and you have to find the measure of one of the arcs, so let's say the measure of this angle right here is 40 degrees. That's a bad example because we just did that. Let's say it's 45 degrees. And we want to find the measure of this arc right here. What would we do? Quit? Yeah, that would be an option. Not a very good one, though. Since we're trying to find the measure of that arc, couldn't we give it a variable? Call it maybe A? If we call that A, then what's this arc over here going to be? No.
360
We-
minus A.
Yeah, we don't need another variable because we know that the two of them are going to add up to 360. And that's only true because both of these segments are starts with a T.
Equal.
Tangent.
Tangent. They're both tangent to the circle. So the two arcs that we get both have the same endpoints. So they're going to add up to 360. So one of them's 360 minus A, the other one's A. Can anybody set up a formula then that's going to help us solve for A? Brittany?
Okay, 45 equals A plus.
Nope.
Wait, where?
Which arc is the bigger one?
360 minus A.
360 minus A minus the smaller one. A divided by 2. 360 minus A is the same thing as 360 minus 2A, right? So we have 45 equals 360 minus 2A divided by 2. All right, let's multiply both sides by 2, and what do you get?
90 equals 360 minus 2A.
Okay. Then what? Subtract 360 from both sides.
Subtract 360 from both.
You guys are acting like you've never solved an equation before. Subtract 360 from both sides, we get negative 270 equals negative 2A. Then what? Divide by negative 2. We get A equals
Negative, or 135.
135. Now, that was not too bad, I don't think, but it was a little bit more algebra than we like to do sometimes. It actually turns out, if you look at the example on your paper, example 38.12, and if you look at this example here, how do they compare? This is 135 here. So how does that angle compare to that arc? In this example here, and the example on your paper, Jimmy?
Like 135, if it was 140, it would subtract 5 and then add it 2.
Oh, you're making it way more complicated. How do they compare here?
From 10.
Let me give you a hint. Add them together. What do they add up to?
360.
180. So the angle and the minor arc, when it's two tangents, add up to 180 in this example. Look at the example on your sheet. Does it work there too? Do they add up to 180? What's 40 plus 140? 180. It's actually always going to work that way. If you have two tangents, and it has to be two tangents, it doesn't work if one of them is a secant. If you have two tangents, then the angle it makes is going to be supplementary. Not really supplementary because supplementary means two angles add up to 180. but they're going to add up to 180. The angle is going to add up to 180 with the minor arc associated with it. Does that make sense? So what we could have done in this problem, going all the way back to the beginning, right here, we could have said A equals 180 minus 45, and that equals 135, and we're done. It's a little bit less work, isn't it? I think it's less work. All right. I'll put that back up there later. Chord-Chord power theorem. Write it down. So this is called the Chord-Chord power theorem because we have two chords intersecting each other. It doesn't matter in what way they intersect, as long as they cross each other inside of the circle, this relationship is going to be true. Now I want you to notice where the letters are. And I did this a little bit funny. I apologize for it. But A and D are two parts of the same segment, and B and C are two parts of the same segment. So when we have two chords that intersect each other, if you multiply one part times the other part of the same chord, that's going to equal one part times the other part of the other chord. Always going to be true. Okay. The important thing, though, is when you use this, you divide it up at the intersection. And it's really simple for this problem. We're going to see a couple of examples later on where it's easy to make a mistake and not divide it the right way. So the intersection of the two chords is what's going to divide it into the two parts. All right, so applying that to this example, it's pretty straightforward, I think. How are we going to set up an equation to solve for x here? Jimmy?
3 times x equals 12.
I don't see a 12 up there.
6 times.
Okay, good. We'll keep the parts in there for now. So 3 times x equals 6 times 2. And the reason that works is because the two chords intersect here. And so we can do this part here times this part here equals this part times this part. So at that intersection, we're going each way on each chord. What do we end up getting for x then?
4.
Pretty easy, right? Okay. How about this example? Somebody set it up for me. 21y equals 14 times 6. I don't know about you guys, but if I didn't want to use a calculator here, there's actually a pretty easy way to do this. To solve this, you would divide by 21 on both sides, right? That's the same thing as dividing by 3 and 7. And what's going to happen? Yeah, the 3 is going to cancel with the 6 and leave it 2. The 7 is going to cancel with the 14 and leave it 2. And we end up with y equals 4. Right? You get the same thing if you use a calculator? I hope. What? So that's just a little trick that'll save you the time of getting your calculator out of your backpack if you don't want to. Yes. Yeah, sure. Why not? All right, here's where it gets a little bit tricky. And here's where I see a lot of people make mistakes. If you want to solve for, let's say, A in this problem. Well, actually, let's solve for B first. Here's what I see a lot, and don't write this down. Don't write anything down yet. So if we're going to solve for B, that means we're going to use that intersection. Do you guys see why? I don't want to use the intersection up here because then I'm going to have this segment, and B is not going to be involved. I see this a lot. B times 6, that's this segment right here, equals 6 times 4. What's wrong with that?
It's because they don't have the A. Oh,
Sam, say that again.
sorry. The A is not included.
Yeah, the A is not included, exactly. So for this part right here, instead of 6, we really should have what? Not 6A.
6 plus A.
Yeah, 6 plus A. 6A means 6 times A, and we're not going to multiply them together. But we need to have this entire part of the chord here. And we don't have that in that equation. Since that would need to be 6 plus a, we can't really solve for b yet, can we? All right, so let's clear that, and let's solve for a using this intersection. Anybody want to set it up for me? What?
Now we can write it.
Yes. Somebody besides Jimmy?
15 times 4.
Okay, so 15 times 4 equals?
8 times 6.
Oh no. You weren't listening, were you?
He's not.
8 times 6 is not going to work, is it? Why not? Yeah, if you do 8 times 6, then you're getting this here times this here, and you're forgetting about this part right here.
You were not listening.
So it's not going to be 6, it's actually going to be 10, which we get by doing 6 plus 4. We'll go ahead and add them together right away. Divide both sides by 10. So divide by 10, divide by 10, which is really 5 times 2. So we get a equals 6. You guys agree with that? Okay. Now we can solve for b. Who wants that one? Jimmy, go ahead.
Okay. B times 6 equals 4 times 12.
Good. So we're using this intersection right here now. So it's going to be 4 on this side and 6 plus 6, which is 12 over here. Divide both sides by 6, and you get b equals 8. Does that make sense? All right, then go ahead and do this one on your own. Okay, go. Which one do you want, A or B?
A.
Okay, so if we're solving for A, I'll get you started here. We're going to use that intersection, right? Yeah? Okay, go ahead.
A times 4
Okay.
equals 2 times 4 times 8.
Oh, nope. So when we split it up right here, what's this part right here going to be? That's 2, right? What's this part here? It's not 4 times 8. 4 plus 8. So it's going to be 2 times... What? 12. So divide both sides by 4 then, and you get A equals 6. Okay, somebody in group 6. Okay, go ahead, Nick.
4b
Okay, so 4 times B equals
8 times 6.
8 times 6. Do you guys agree with that? Yep. Divide both sides by 4 and you get B equals 12. Any questions about that one? Okay, flip it back over and... Uh-oh. There is the secant-secant power theorem. Why is this called the secant-secant power theorem? Why the secant-secant? Yeah, both of those segments up there, the one with A and B in it and the one with X and Y in it, those are both secant segments. You guys remember the definition of a secant segment? Secant segment is a part of a secant with one endpoint on the circle and one endpoint outside of the circle. Yes? Yes. So not only do I want you to write down, I want you to write down that outside part times whole equals outside part times whole, but then we're going to use that to come up with the actual equation that we're going to use. I'll give you a second to do that. For this segment right here, what is the outside part? B. Okay, what is the whole thing? b plus a, or if we want to go alphabetical order, which is what we typically do, a plus b. So on one side, we're going to have b times a plus b. On the other side, what's the outside part?
Y.
What is the whole thing?
X plus Y.
There you go. That is the secant-secant power theorem right there. I actually like remembering this, the verbiage of it, outside part times whole equals outside part times whole, because that means a little bit more to me than some equation with variables in it that only really apply if you have those variables in that problem. And so I like that, remembering the verbiage a little bit better. So let's put that to use then. In this example, what's that? You can copy it. Can somebody set up the equation for this one? Jimmy?
3 times 3 plus 6.
Okay. So you have a choice here. You can write 3 plus 6, but you know what 3 plus 6 is, don't you?
Yeah.
So what is that? 9. I would just write 3 times 9 if I were doing this problem. So 3 is the outside part of this segment, and 9 is the whole thing. 3 plus 9. Don't multiply it, add it. Equals, outside part of the other one, Jimmy?
2.
And the whole thing?
2 plus x.
2 plus x. We can't really get away from that one, right? Now what?
And
Do math. Okay, there's a couple different ways you could do this. I would just multiply it out first. So we get 27 equals 4 plus 2x. Subtract 4 from both sides, and what we get? 23 equals 2x. And so that means that x is going to equal 23 over 2. Or 11.5 or 11.5 would also be appropriate. Does that make sense? Okay, how about this one? Somebody set it up for me. I'll pick somebody. Nancy, what's the outside part of this top segment? Okay, what's the whole thing? What's the whole thing? So this is the outside part here. What's the whole thing? How far is it from here to here? We're going to put that in there. What'd you say? 3 plus 9, which is? 3 plus 9 is 27? 12, okay. Abria, what's the outside part of the other one? Z, and what's the whole thing? Okay, I'm going to put the z plus 5 here because that's going to make a little more sense to us. Okay, what do we do to solve this? Alicia? What would you do to solve this equation? Don't say quit. Okay, so we get 36 here equals... Okay. And what would you do next, Weston? Aaron?
Z squared, or subtract 36 from both sides.
Oh,
Z squared.
good. So we want to set it equal to 0, so we'd subtract 36 from both sides. And Aaron, tell me again, what would you get?
Z squared plus 5z minus 36 equals 0.
Okay. And who's going to help me factor that? I'll take volunteers for this one. Carly?
Z minus 4 and Z plus 9.
You guys agree with her? Alright, so we get z equals... What do we get, Sam?
4 or negative 9.
Okay, and are both of those logical answers? Do they both fit? Which one doesn't? the negative 9, right? The negative 9 doesn't make sense because it's negative and it's what? What is, it's a measurement, right? It's the measurement or the length of a segment, and a length can't be negative. So we get z equals 4. Cool? Okay, next one. So I put this picture on here before we get to the next example. This is what the next example looks like, right? Even though AB is a tangent segment and not a secant segment, we're going to use the same formula. We're still going to use outside part times whole equals outside part times whole. And it's going to be just a little bit different. It's going to look a little bit different because one of them is a tangent segment. You guys may remember seeing problems like this from the book, and we're going to end up with the same formula as the book, but by using the secant-secant formula. So let's start with this segment. Let's start with the new part. What is the outside part of this one? It's 12, okay. What is the whole thing? 12 times 12 is 12 squared, right? There we go. Okay, what's the outside part of this one? 9. What's the whole thing? C plus 9. Alright, and then do math. As one of my students likes to say. I'm not going to put all the math on here. You guys know how to do algebra, right? What do you end up with for C? Chrissy, what'd you get? You got 63? I think I got 7. Do you guys agree with 7?
I agree.
Okay, cool. As long as Sam agrees, we're good. Does this make sense? Okay, next one. Just like the last one, we're going to use the same formula. Outside part times whole equals outside part times whole. What's the outside part for our tangent segment here? What's the whole thing? Well, the whole thing is A. So we're going to do A times A, and that's going to give us A squared. And what's the outside part for the secant segment? What's the whole thing? 3 plus 9, which is 12. So we get A squared equals 36, which means that A is equal to 6 or negative 6. But negative 6 doesn't work because it's a length, so A equals 6. Okay? One more. What is the outside part for our tangent segment? What is the whole thing? Well, the whole thing is 4, so we're doing 4 times 4, which is 4 squared. Or you could just put 4 times 4, that would be okay too. Equals outside part, B, times the whole thing. What is it? B plus 6, okay. This looks like it's going to be a quadratic equation again. So we're going to get B squared plus 6B minus 16 equals 0. What'd you get, Matt, when you factored it?
B plus 8 and B minus 2.
So B could equal what?
2 or negative 8.
And which one doesn't make sense?
Negative 8.
So B equals 2. Any questions about this?